Okay, guys, here we go with notes on 11.5 areas of similar figures. This is 420 Monday, page 141 of your notes. So I'm going to zoom in and see if I can get you a little bit clearer and a little bit sharper here. So start on this left side first. So you remember that if two polygons are similar, then their perimeters are proportional to the scale factor between them. The areas of two similar polygons share a different relationship. So the areas share a relationship in which they are k squared, or the scale factor squared, instead of just k. So if two polygons are similar, then their areas are proportional to the square of the scale factor between them. So if we have these two figures, we say they're similar in the areas of each of the figures, or in proportions. So in other words, FG, this length, over AB, this length, the two proportional sides, we just take them and we square them to get that similar identity. So example 1. Here we go. So if the two triangles are similar here, it says the scale factor between the two then are 15 divided by 12, or 5/4. So the ratio of their areas, okay, instead of just the sides, are 5/4 squared. So the area of this 5/4 squared, we would say the area of the triangle PQR over 30 is 25 over 15. Now, where did we get 30 from? It said the area of triangle JKL is 30 square inches. So here's JKL, 30 square inches right here. So we're going from a smaller triangle to a bigger triangle. So the scale factor squared has to be a number greater than 1, because we're going larger. We're going from this smaller figure to the larger figure, trying to find its area. So what you do is then take the square of the ratios, 25 over 16, and multiply it by that 30 to get the area of the larger figure, and that's how you would work these problems. So the area of this triangle PQR is about 46.9 square inches once you work all that out. So here's a couple examples down at the bottom, then we'll go to the next examples. So let's say we have I'm trying to square this up. For each pair of similar figures, find the area of the green figure. So we're going from the blue figure to the green figure, so you can see you're going smaller. So the ratio of the sides must be less than 1. So 5 over 8. The 8 ratio of the areas, then you square the scale factor. So 5/8 squared times your area of this figure will give you 12.5 square centimeters, or the area of the green one. Same thing here. You're going from a small figure to a large figure, so the scale factor has to be greater than 1. Then the area of the squares, you have to, the ratio of the areas of the squares, you square the scale factor to get that. So you take 8/6, the scale factor, square that, multiply it by the area of the blue figure to get the area of the larger green figure, or 24 square feet. And that's how you work the very simple problems once you know each figure. So now let's say we're missing a similar, we know the scale factor, we're missing measures to the similar figures. You can use the areas of the similar figures to find the scale factor between them, or a missing figure. So you're working kind of backwards. So let's say you have the area of triangle ABC is 150, so that's the larger one, and the area of the smaller one in green is 54. The figures are similar. Find the scale factor and then find the value of x. So first of all, let k be the scale factor between the two figures. So in this case, 54 over 150, 54 over 150 is equal to k squared. So therefore, if you simplify 54 over 150, you get 9 over 25 equals k squared. Take the square root of both sides, and you get 3/5 for k. Now, so the scale factor is 3/5. Use the scale factor to find the value of x. So you know that JH is x over DC 10. So x over 10, you want that to be smaller than 1, is equal to 3 over 5. which 3 over 5 is smaller than 1. Then you do the cross product, so 5x equals 30, divide by 5, and x equals 6. Or you take 3/5 times your 10, and you get 6. So to confirm it, you can work that out, but you all know that 6/10 equals 3/5. So that's how you work that type of problem. So here's 2 examples at the bottom. So let me see if I can get all these 2 examples in one picture. Here we go. See if that's square. Good enough. Good in there. Okay, so for each pair of similar figures, use the given areas to find the scale factor of the blue to the green figure. Then find x. So blue to green, we're going to go larger. But we say that 50 divided by 72 equals k squared. 50, that area divided by that area is 25 over 36. When you simplify it, take the square root of both sides and you get 5/6. So there's k. Now to find x, we say 5/6 equals x over 6. Product of the means equals product of the extremes, and x equals 5. Or you can see if that's 5/6, that has to be 5 as well. That's how you get x. Same thing here. 64 over 400 equals x or k squared. Simplify that to 4 over 25. Take the square root of both sides and get 2/5. Then you substitute in and make a proportion. So 2/5 equals x over 40. And then 5x equals 80. Divide by 5x equals 16. And that's how you find the scale factor and what one of the sides might be, kind of working backwards. All right, good luck with that.